Our night sky is a truly fascinating thing. There is the sun, the moon, the rest of the Milky Way, and if you're at a very high elevation, you might be able to even make out the Andromeda galaxy quite large in the sky. Well, this is just the sky on our home planet Earth. The skies on the other planets of the solar system might look far, far different from what Earth looks like. Take Mercury, for example. The sky would mainly look like Earth's sky, despite the fact that the sun would appear massive, almost more than twice as large than the sun on Earth's sky. The sun on Mercury would also appear quite a bit brighter than the sun on Earth's sky, making it even harder to look at than the sun on Earth's sky. On Venus, you would not be able to see anything much, since its atmosphere is so thick and so dense. You would be pretty lucky if you could make out the mountains in the distance, despite the fact that you can make out the sun or any other celestial body. Mars is very interesting. Its sky would actually look quite interesting. In Mars, the sun would appear about 2/3 of its size, and the rest of Mars's moons, Phobos and Deimos, two little asteroids that orbit very close to Mars, would appear quite large in the sky too, about half the size of what our moon itself looks like in the sky. Occasionally, Phobos and Deimos will eclipse the sun, causing a giant hole in the sun. It would not be as spectacular as the lunar eclipses we see on Earth, but the eclipses of the Martian moons would still look quite fascinating. Since Jupiter is a gas giant, you cannot stand on it, but if you were to stand on one of its moons, Ganymede, it would be quite interesting. Jupiter would be the main star in the sky. Even on the night side of Jupiter's moon, Ganymede, it would appear quite bright. Jupiter would illuminate the Ganymede's night side, making it still not too dark. You would also be able to make out the rest of Jupiter's moons. Some interesting moons might include Callisto and Io. You might also be able to make out Europa, the smallest of Jupiter's Galilean moons, if you look very closely. Saturn is also a gas giant similar to Jupiter, but a little bit smaller in size. Although you cannot stand on Saturn, it has a moon named Titan, which actually has oceans of liquid methane. On Titan, Saturn would appear quite large in the sky, far, far bigger than what the moon appears in our own sky. It would light up the night side of Titan, making it quite bright even though it's night. Uranus's moon, Miranda, is an icy moon that orbits Uranus at a quite close distance. Uranus would be very large in the sky, and it would often eclipse the sun. You might be also seeing black dots on Uranus. These black dots are not physical parts of Uranus. It is just the shadows that Uranus's 14 different moons cast on Uranus itself. One interesting thing is Pluto. Pluto has a moon named Charon. It actually is not a moon. Calling it a moon would be quite controversial, mainly because the moon is half of Pluto's own size. Charon does not exactly orbit Pluto, yet they kind of orbit around each other. Imagine a point where Pluto and Charon circle around. This point is called the barycenter. Pluto and Charon are often called a binary dwarf planetary system, which basically means a dwarf planetary system in which two dwarf planets orbit one another. Pluto and Charon are the main part of the Pluto-Charon dwarf planetary system, but there are a few other moons, including Styx and Nix. Although these names might appear strange, the moons are even stranger because their orbits are so out of whack that it's almost impossible to predict what the view would look like from Styx and Nix. Since Styx and Nix orbit Pluto and Charon at quite a far distance, the gravitational anomalies from Pluto and Charon would drastically orbit differences. Pluto and Charon relativity to Styx and Nix would be far different, which means that the orbits will not be in shape. Rather, Styx and Nix would circle around Pluto and Charon, often jumping off orbit, coming back into orbit, sometimes swooping very close, after swooping far away and coming close again. This orbit might vary. This is because Pluto and Charon are a dwarf planetary system. This means that the gravitational pull on each side of the moon will vary greatly, causing the moon to spin out of orbit and coming back into orbit again. It is very, very likely that far in the future that Styx and Nix might collide with Pluto or Charon, changing the landscape of Pluto and Charon forever, or otherwise might be ejected into space, or might be ejected into orbit with the Sun, which means that we would have two extra asteroids in the asteroid belt. These could also be comet-like bodies. The night sky from Pluto, as I was saying, Charon would appear in massive. Charon would almost certainly eclipse the Sun each day, sending Pluto into a long period of night before the Sun is re-eclipsed. This means that the view from Charon would also be quite cool because Pluto would eclipse the Sun even more often because Pluto is about twice the volume of Charon. This means that the other moons of Pluto, such as Styx and Nix, would also be seeing this. They might have a double eclipse of the Sun, which would look fascinating and is not observed yet. Also on Pluto, you might be able to make out some of its other moons. This is basically the end of the presentation.